popular use for small solar panels is charging a phone or other USB device. If you have a small panel, 3 to 5 watts, it will charge your devices, but they're 12 volts and their actual power point is around 17 to 18 volts. And you drop that down with a converter to your 5 volts. The problem you have with small panels is that most times of the day the light level is not up at their peak power. That's only around 2 hours around noontime where you can actually get the most power out of them. And then you have clouds, everything else will happen. Sometimes what happens is these can't supply the current that's needed, and from this power curve here you can see what happens is when you draw the excess power, the voltage drops. And with the voltage drop, it's the same current but lower voltage, and you can see that causes these converters to try and draw even more power. It's a death spiral that you can't recover from. So these will work very poor in a low light level condition. This little circuit does a modification, so it always keeps the panel at power point, and you get the maximum power transfer to your USB port. What we do is it's a 2596 board. These are common, they're a couple bucks. This pin number 5 is an on-off pin, and you can take a little screwdriver underneath that pin and you can heat it up with a soldering iron and it'll pop right up, and you can attach a wire onto it. Over here we have a 15 volt zener, so if you have say 18 volts and you subtract 15 from it, you have a 3 volt window that you're looking at, and so it magnifies the sensitivity. That just gets fed into a transistor. When the transistor sees that the voltage panel is enough, it pulls this pin number 5 low. That turns it on. You got the 22K resistor to pull it back up. And this 22K is in there for protection. This pin can only see so much voltage, and by dividing this voltage in half with this voltage divider, you can be sure that even if with a counterfeit chip, you won't have problems. So this 15 volt zener, sometimes people don't have zeners easily access to them, and even ordering just 1 or 2 zeners online is kind of expensive with shipping. If you have a bunch of LEDs, you can put LEDs in series. Each one of these LEDs is about 1.7 volts if it's a red one. 8 LEDs would give you enough voltage drop. You could actually put 16, if you had a bunch of small diodes, you could put 16 diodes in series, and that would provide some voltage drop. And that would provide actually temperature tracking for the panel. The power point changes. The voltage goes up when it's colder, so if you're a winter camper, you'd want to set this at a little bit higher voltage. And if you're camping in the sun, it's hot, bright sunlight on this, this panel point voltage will drop, so you want to set the voltage lower. But generally that's seasonal. It doesn't vary much. Generally the panel gets up to a temperature, and it's typically the same for day to day. There are other small boards now. These XL9006 are very common, but they're actually just the opposite. It's a pin number 2 that changes, and it's exactly the opposite. Instead of a low turning it on, a high turns it on. So there's a totally different circuit. I'll be doing one of those in the future. Be a little careful if you go to look up a 2596 board on eBay. There are people selling MP2307 boards and calling them an LM2596. This again is opposite of how that this board works, so you can't use it. There will be some future videos. But keeping the panel at power point is the most effective way to get all the power out that you want. fairly simple circuit. I just hope you try it. You know, a lot of people are afraid to do a little soldering. It's not all that difficult. And if you have any questions, just ask. Thanks for watching.